All right, and welcome back to DIYDSP.com. This is Noah Vaughter, instrument designer, and today I'm going to tell you about an executive decision I've made regarding this generator. So if you've seen the last few videos, you know that this is a stepper motor with an encoder, and I've been planning to put it into a new instrument that will let me actually see how fast the player is bowing the instrument, generating electricity, and allowing the synthesizer algorithms to respond to that movement very intelligently. And my original plan was to build this into the new instrument and keep this other one operating that I've got over here. So this is the first pyramid eel here, and it works. It just doesn't have the speed and direction measuring generator encoder combination on there. And I wasn't going to take this one apart and modify it because I didn't want any downtime. That's always been a problem of mine as an instrument designer, and I know some of my instrument designer friends have felt the same thing. You always have to make something new because if you disassemble the old, you don't have it and you have some downtime, or maybe you break it and it never recovers. So I had a couple of revelations while I was thinking a lot in the last couple of days, and I realized a couple of things. First, I can put this generator in here without a tremendous amount of downtime. Really, I can just swap that stepper motor out for one of these two stepper motors, connect it where it exists, and the instrument will play exactly the same. Second is that it's going to take a long time, really, to get the new instrument going. You know, the maker space nearby is not available right now because of the virus. And the circuit board that I'm planning to use that has all kinds of additional current and voltage measuring functions on it it's still under design. I've been working on it, but it's still got to be manufactured, and then I got to solder everything on there. And in the meantime, I did a live Facebook concert last Friday, and I was listening to this, and I love the sound of it, but I really want that variable speed. And I'm not going to be able to use the current and voltage measurement stuff yet, but let's see how far we can get in the next couple weeks until the new circuit board is ready just with the voltage measuring. So with that, let's install the new generator. So first thing I'm going to do is I'm going to start to take this apart here. So what we do is we just slide that right off. That's my special hubs and the Lego wheel. There's the generator right there. You can see some of the rubbers rubbed off there. Not great, not perfect alignment, but whatever. And let's see. I could just pop this off, but then the motor would just like fall down inside. So I guess what we're gonna do is take off a bunch of these screws so that we can get to the back. All right, hang on a sec. Screwdriver out. I should probably get my power driver out because this is going to go slow. Hold on. Okay, this should go a lot faster with this guy here. Just put it on. There we go. Oh, we can even put it on 2. Haha. Super fast. Hope we didn't. Oh, I chewed up the brass a little bit there. Start off slow. Okay, just like that. Okay, that's all the screws off. So now we can slide away the panel. And I think you saw this view in a video the other day. You could see there's the speakers down low, down there. And then up in the middle, there's all the knobs that I just fixed the other day, and here's the generators. So, let's take these off very carefully here. Good. Well, that's interesting. I seem to have soldered those into place. Okay, we'll have to take care of that later. Oops. Yeah, I think the idea with the soldering was that I wanted the generators to be part of the instrument, and then they actually go to some speaker terminals inside there. And then you could put on different motherboards in the back there. So if you have different generator electronics, then you could still use the same generators. I didn't really anticipate changing the generators, but whatever, it's flexible enough. So now that motor is loose, tell you what, just for fun, let's snap it on for a minute. Yep, and you can see, press a button and no sound. Drive the generator. So that's kind of fun. Anyway, all right, so looks like I have to desolder these, and it looks like they go in pairs like that. So let me go get the soldering station. I'll be right back. Okay, soldering iron is heated up. So let's gently remove this motor. And the interesting thing is I can use this on the next instrument because the way it works is the two motors move at the same time on the instrument when you bow it. They physically touch each other, and the bow connects the two rubber Lego tires. So what that means is you only have to put the special measurement stepper motor on one half, and then you can have a regular motor. So I'm going to leave that smaller stepper right there, and I'll put this smaller stepper on the new one when I make it. And now let's see if that other one fits in here as good as I've been hoping. So you've probably seen this in the other videos before. It's almost the same as that other motor, except it is a little longer. It's got a higher stack, so that means it's going to put out more power. And it's also going to be a little harder to turn. I am a little concerned about that. I bought the bigger stepper motors just because I'm always hungry for more power and more volume. But it is true at some point it just gets too hard to turn. So we'll have to see how we come down on that at some point. All right, let's turn the base. Actually, let's not turn the base because then you can't see what's going on. Now the other thing is this stepper motor has this huge chunk on the side here, so that's got to face out of the way somewhere. So I'll try putting it down there. Okay. So of course, because it's a standard size, it fits right in the faceplate. It is so big though, it's colliding with this height adjuster here. Tell you what, let's take that out of the picture temporarily. Put it back in. So that just actually unscrews there. Oops. Oh God, I removed the insert from the wood. Whatever. Leave that up there for now. Okay, so it does fit in there reasonably, even when you turn this on the dolly. It obviously rubs against some of those other wires, so I have to move those other wires out of the way, but I think it's okay. All right, let's get in there and mount the thing in place. Okay, so to mount these, we just pretty much do the inverse, where these holes here is where you put the generator through. Only real difference is these are now metric screws. So when you get these stepper motors, they'll sometimes have metric, sometimes imperial. You never really know. So the spec sheet just said that these were M3s. And the other thing is I didn't know exactly how long they have to be without doing a 100% deep CAD dive. Don't really know. So I'm gonna try the long ones first. Is that lined up? Whoops. So let's bend those wires down actually. Alright, so put that through. First without a washer, just to see where we are. Normally use a washer. Oops, see if it's too long or not. Yes, that seems ever so slightly long. The washer might help, but the problem is you need a lot of grip because this is wood here. Someday I'll have them made out of metal, but the wood has give to it. So, all right, let me get that washer. The thing with the The wood having give is not ideal, but it's way easier for me right now to manufacture things out of wood. Maybe someday, when these are rolling off an assembly line, they'll be made out of metal there. So I got the washer. Okay, and turn it there a little bit. Is that good? Okay, quite see that's misaligned. Alright. Oh, where'd the screwdriver go? Go. Alright, so the first one's in place. I'm able to get it pretty tight, even with this cheesy screwdriver. Alright, I'm going to do the next 3 now. Hang on. Okay, so now all 4 screws are on there in place. Let's replace the tire on there. So I'm feeling around for where the index, the flat edge is. Put it right on like that. Okay, so you hear the crinkling. That means that, we got some power coming through. So technically, this instrument is already restored to working status with the new motor. It just happens to be that we're not even using the new motor yet, but that can be cured. So what we really just have to do is, remember we unsoldered those wires. We have to take this connection that comes off of there and just probably trim the ends of these off and solder it onto there, so we'll get the full power of this motor driving the thing as well, because I do like having lots of electricity, lots of watts coming through, lots of joules. That leads to huge volume and long running time, and those are really the name of the game here. Okay, so tell you what, I'm gonna get my wire strippers and I'll be right back. Ta-da! Okay. So I'm first just going to snip the ends off this. I use a lot of this kind of wire here. Now we're going to pull these off one by one. This is something I remember my father teaching me how to do when I was a kid. How to just separate wires and then strip them and tin them. This means a lot to me right now because my father just passed away on Sunday. So I'm home from my normal job this week and morning, and it wasn't bad enough that there was the COVID virus going on, but then my father had to pass away in the middle of it. So I've honestly been a little bit sad lately. So definitely remembering Ted. He was a hell of a brilliant guy. Although my parents separated and divorced when I was very young, he had an outsized influence on me in the few years we had together. I saw him off and on throughout my life, and I was always shocked by how much my personality resembled his, like little personality quirks, our love of precision, our sometimes twisted sense of humor, all of these things. It's just, I was so grateful for him giving me life and teaching me so many things. Another thing he taught me that was very technical and important was the powers of 2. So when I was a little kid, like 3 or 4 years old, he would say, "So what's 1 times 2?" And I would say 2, and he'd say, "What's 2 times 2?" And I'd say 4. And then so on, and he would get me to go up, maybe when I was a kid, to like 64, but he taught it to me like a game. So later on in my life, I just enjoyed it, and I learned the powers of 2 higher than that. I learned them, at various points, up to about 33 million. 33 million is a fun one. That's the 26th power of 2, 33,554,432. Because it goes 33554432. So that's kind of an interesting one. And that has helped me tremendously in my career as an engineer, as a computer programmer, particularly a computer programmer who, and combined with electrical engineer who does a lot of electrical engineering. So I'm just so grateful for just that little game he taught me. And from there I learned how to do a lot of things just as a game to amuse myself that were very practical. God, I sure miss you, Dad. I wish you could be seeing this video now. I wish you could see the electric eels when they're complete and in their full glory. But looks like we'll have to wait for heaven for that. All right, let's rotate this. Yep, Dad taught me how to solder when I was a kid, and I do it just like he showed me. And I've shown dozens of people how to solder over the years. It's just one of those skills that's so useful. Of course, he taught me lots of other things that are non-technical as well, but and he was a radio expert. So my father joined the Navy around 1950 or so, when radio was first coming out and it was very much dependent on tubes and stuff. And he got an education in the Navy on how radios work, and it just really resonated with him. He was very good at it. And so after 4 years, they tried to get him to sign up more. And he'd gotten one of the highest rates of promotion. They couldn't promote him higher, but he just said, "No, thank you. I want to work in the commercial world." And that's what he proceeded to do. All right. Let me give this a quick test now that I've soldered this generator up to where the old one used to go. Now all that means is I didn't totally break everything, because it could still be powered by the other motor. So let's disconnect the other motor briefly. So the other motor is in the lower row, and I just added to the upper row. Remember that when we turn this around. Okay, so just gonna drain off that charge. This is the area of action here. If you saw my building vlogs, then you would recognize this is the terminals where the generators come in, some of the temporary charge capacitors, regulator, battery for the CPU amplifier, and then that's the output to the built-in speaker. So we just connected the motor at the top. So let's take off the bottom one for a second, and let's hope it still works. Yeah! Okay, that's good. All right, so the important thing here is I still have a working instrument and this generator is now a smart generator. What does that mean? Does it mean it's connected to the internet? No. It means that it can tell how fast it is moving. And that is going to be tremendously huge for implementing sound algorithms, for making this into a very musical instrument. So connect that back up. I'm going to turn it around one final time so you can see what I'm doing as I'm talking about it. Okay, so currently the way this instrument works is it gets louder when you play it louder. So I'll do it quiet. And play it loud. It's kind of quiet, and then it'll get loud. And you can hear it decay a little bit at a kind of natural decay rate. The thing is, though, this instrument none of the electric eels so far have really had a good idea how fast they're moving. Wouldn't it be nicer if the movement here matched the sound a little better? So instead of letting it decay faster, it could either bleed off some of the power into a waste resistor, or make it louder and use up the power, or just make it quieter, with the algorithm controlling the volume. So give the player a lot more control and expression and meaning to the music. Well, now that I've got this fancy new generator in here, I am able to do that. Okay, the only caveat to this is I've not hooked it up yet and written all the software. So you see we got the wire coming off of the generator, and like in my previous videos, it goes to this VGA connector, and then it uses basically 4 pins here. There's a power, a ground, and then 2 quadrature signals that I can use to compute it. And I don't, there was a Nucleo, a little dev board attached to this. I don't know where, it must have fallen off somewhere. Maybe it's in my car or I'm going to step on it like a Lego. But anyway, my current plan, I could definitely connect these wires to the other CPU, but I think in my first incarnation of this, I'm going to generate an analog output that represents the speed, and then a digital output that represents the direction. And then those are simply going to be inputs onto the other CPU. There's a couple reasons for this. Basically, the other CPU is only running at 70 or 80 megahertz, so it's not terribly fast. I don't want to introduce the additional computational load from this. Second, I want to have like a degree of isolation because I still want to figure out how to use the internal hardware registers to read the quadrature in here. You know, these STM chips have the internal hardware registers to be able to do it to basically use no CPU power. So I want to do that, but I don't want to also have to be thinking about the other firmware that's in there. You know, you could mess that up. It takes longer to compile. It's more to look at on the screen. Just a little bit of isolation to figure out, and then I'll reintegrate it. And you know what else is funny? While I'm here, I think if you watch one of my other videos where I was putting the knobs back on, I was missing one. I just found it. It's down here. It's wedged in between the speaker. Okay, so there we go. So stick around for the next couple videos where I'm going to find my Nucleo. I'm going to generate the analog output, and then I'm going to attach the analog output to the existing CPU here. And in the meantime, I am going to keep working on the totally new instrument with the current and voltage measurements. So, you know, like, subscribe, become one of my patrons on Patreon so you can follow this thing and I give a little more detail. And yeah, no, it's just really blast. I think I got big visions for this. People are going to be playing these on a lot of different forms. It's going to make a lot of beautiful music. We're going to beef up the synthesis algorithm. I was just having a web conference with one of my collaborators, Jimbo, last night, and he's just been going off on the sound algorithms and some of the other aspects of instrument development. And that's all going to be working its way over into, it's already starting to work its way into this. So thank you very much. Be safe from the virus. Bye-bye for now.